I think one thing that I've been seeing over the past few years that I find very um, kind of interesting is this move away from cloud and back into your own data center. I think having control over your data is something that's incredibly important to basically everyone now, and I think it's to find the happy medium as a DevOps engineer between all of the wonderful cloud APIs that you can use and you know going in the server room and kind of hooking things up. There's probably a happy medium there somewhere that I think is an area that is going to start growing in the future.
Hello, everyone. Welcome back to another episode of Simplyblock's Cloud Commute podcast. Today, I'm joined by Steven Sklar from QuestDB. He was recommended by a really good friend and an old coworker who's also at QuestDB. So, hello, Steven, and good to have you.
Thank you. It's really a pleasure to be here, and I'm looking forward to our chat.
All right, cool. So maybe just start with a quick introduction. I mean, we already know your name, and I hope I pronounced that correct. But what else is to talk about you?
Sure. So I kind of have a non-traditional background. I started with a degree in economics and finance and worked on Wall Street for a little bit. I like to say in most of my conference talks on the first slide that my first programming language was actually Excel VBA, um, which I do still have a soft spot for. And I found myself on a bond trading desk and kind of reached the boundaries of Excel and started working in C Sharp and SQL Server. Realized I liked that a lot more than just kind of talking to people on the phone and negotiating over various mortgage bonds and things. So, I moved into the IT realm and software development and have
Mhm.
been developing software ever since. So, I moved on from C Sharp into the Python world, moved on from finance into the startup world, and I currently am at QuestDB, as you mentioned earlier.
Right. So maybe you can say a few words about QuestDB. What is it? What does it do? And why do people want to use it?
Sure. QuestDB is a time series database with a focus on high performance, and I like to think ease of usability.
Hmm.
So we can ingest up to like millions of rows per second on some benchmarks, which is just completely like mind-blowing to me. It's actually written primarily in Java, which doesn't necessarily go hand in hand with high performance, but we've rewritten most of the standard library to avoid memory allocation. So,
Right.
it actually truly is high performance. We've actually been introducing Rust as well into the code base. You can query the database using plain old SQL.
Hmm.
And, it really fits into several use cases like financial tick by tick data and sensor data. I have one going on in my house right now, collecting all of my smart home stuff
Right.
from Home Assistant. And I mean, yeah, I've been here for around a year and a half, I want to say, and it's been a great ride.
Cool. So you mentioned time series, and I'm aware what time series are because I've been at a competitor before that. So Jaromir and I, we did slightly different directions, but we both ended up in the time series world. But for the audience that may not be perfectly aware what time series are, you already mentioned like tick data from the financial background. You also mentioned like Home Assistant and IoT data, which is great because I'm doing the same thing. For me, it's mostly like energy consumption and stuff. But maybe you have some more examples.
Sure. Kind of a canonical one is monitoring and metrics. So,
Hmm.
any kind of data, I think that has a time component because it's, and I think you need a specialized database. A lot of people ask, well, why not just use Postgres or, any of the common databases? And you could, but you're probably not going to scale, and you're going to hit a point where your queries are just not performant. And time series databases, in many cases, ours in particular as well, I can speak to, is a columnar database. So it stores data in a different format than you normally would see in traditional database. And that makes querying and actually ingesting data from a wide range of sources much more efficient. And you kind of like to think of it as, and I don't want to put myself on the spot and do mental math, but imagine if you have 10,000 devices that are sending information to your database once a second. Like, it's not that big of a deal. But maybe, let's say you scale and you end up with 1 million devices. All of a sudden, you're dealing with tremendous amounts of data going into your database that you need to manage. And that's a different problem, I think, than your typical relational database.
Right, and I think you brought up a good example. It's most of the time when we talk about devices. As I said, I'm coming from a kind of similar background. It's not like a device just sends you a single data point. When we talk about connected cars, they actually send like, I don't know, thousands to 100,000s of data, like position information, all kinds of metrics about the car itself, the electronics, and all that kind of stuff. And that comes down to quite a massive amount of data. So yeah, I agree with you. An actual data time series database is super important. You mentioned columnar storage. Maybe you can say a few words about how that is different from, I guess, your Excel sheet.
Sure. Well, I guess I don't know if I can necessarily compare it to my Excel spreadsheet, since that's its own weird XML format, of course.
Right, fair.
Uh, but columnar data, I guess, in different than, let's say, tabular data in your typical database, is tabular data is stored in generally table format, where all of your columns and rows are kind of stored together.
Right.
Versus columnar data store, each column is its own separate file. And that kind of makes it more efficient when you're working in a time component, because time is generally your index. You're not really indexing on a lot of kind of like primary key type things. You're really just mostly indexing on time, like what happened at this
Right.
point in time or over this time period. And because of that, we're able to optimize the storage model to allow faster querying and also ingestion as well. And just for clarity, like, I'm not a core developer. I'm more of a cloud guy. So I hope I got those details right, but
I
don't
think
call me
you
on it, I
basic,
guess.
yeah, I think you get the gist of it. But for QuestDB, that means it still looks like a tabular kind of database. So you still have like your typical tables, but the individual columns are stored separately. Is that correct?
Correct. Yep.
Okay, cool. So you said you're a cloud guy, but as far as I know, you can install QuestDB locally on-prem. You can install it into your own private cloud. I think there's the QuestDB Cloud, which is the hosted platform. Well, not I guess. I know that it is. So maybe what is special about that? Does it have like special features, or is that mostly about the convenience of getting the managed database and getting rid of all the work you have to do when you run your own database, which can be complicated?
Absolutely. So actually both. Obviously, you don't have to manage it, and that's
Yep.
great. You can leave it to the experts. That's worth already the price of admission, I think.
Hmm.
Additionally, we have the Enterprise, the QuestDB Enterprise, which has additional features. Um, and all of those features, like role-based authentication and replication, that's coming soon, and compression of your data on disk, those are all things that you get automatically through the
Right.
cloud.
Okay. So that means I have to buy QuestDB Enterprise when I want to have those features on-prem, but I get them on the cloud right away.
Correct.
Okay, cool. And correct me if I'm wrong, but I think from a client perspective, it uses the Postgres protocol. So any Postgres client is a QuestDB client, basically.
Absolutely. 100%.
All right, so that means as an application developer, it's super simple. I'll basically drop in QuestDB instead of Postgres or anything else. Cool. So yeah, let's talk a little bit about the cloud then. Maybe you can elaborate a little bit on the stack you're running on. I'm not sure how much you can actually say, but anything you can share will probably be beneficial to everyone.
Of course, yeah, no problem. So we run on AWS, we run on Kubernetes, and we also, I guess one thing that I'm particularly proud of is an operator that I wrote to orchestrate all these databases.
Hmm.
So our model, which is not necessarily your bread and butter Kubernetes deployment, is actually a single tenant model. So we have one database per instance.
Hmm.
And when you're running Kubernetes, you kind of think like, why do you care about what nodes you're running on? Shouldn't, all that be abstracted away? And I would agree. We primarily use Kubernetes for its orchestration, but we want to avoid the noisy neighbor problem. We want to make it easy for users to change instances
Hmm.
and instance types quickly. We want users to be able to shut down their database and we still have the volume. So all these things, we could orchestrate them directly through Kubernetes, but we decided to use single tenant nodes for that.
Right, right. So let me see. So that means you're using Kubernetes, as you said, mostly for orchestration, which means it's more like if the database for some reason goes down, or you have to have a maintenance, or you want to upgrade it. It's more about the convenience of having something managing that instead of doing it manually, right?
Exactly. And so I think we thought, okay, and this is a little bit before my time, but you could always kind of roll your own cluster, but
Right.
there's so many things that are baked into Kubernetes these days, like monitoring and logs and metrics and networking and DNS and all these things that you kind of like don't necessarily want to spend all my time on. I want to build a
Hmm.
product. And by using Kubernetes and leveraging those components, we were able to, build the cloud incredibly quickly, get us up and running, and then now expand upon it in the future. And that's why, again, I mentioned the operator earlier. That was not originally part of the cloud. The cloud had and still has, in a more limited capacity, what we call a provisioner. So
Hmm.
basically, if you're working if you're interacting with the cloud and you make a new database, we'll basically send a message to a queue, and that message will be picked up by a provisioner. And
Hmm.
previously, that provisioner would say, okay, you want a database, let's make a stateful set, let's make a persistent volume, let's make these networking policies, let's do all of these things. If there's an error, we can roll back and we have retries. So it's fairly sophisticated. Um, but we ended up moving towards this operator model, which instead of the provisioner managing each of these individual components, it just manages one QuestDB resource. And
Yeah.
our operator now handles all of those other little things. So I think that's much more flexible for us in terms of simplifying the provisioner code
Hmm.
and also by adding new features, instead of having to work in this ever-growing, web of Python. Now it's really just adding like a snippet here and there to our reconciliation inside of operator.
Right. You mentioned that the database is mostly written in Java. Most operators are written in Go. So what about your operator? Is it Java?
It's Go. It's
It's
Go.
Go. That's fair. To be honest, I think the vast majority is. Um, so you mentioned AWS, but I think that was you mostly talking about QuestDB Cloud, right? I think
Yes.
from a user's perspective, do I use a Helm chart, or do I also use the operator to install it myself?
Yeah, so the operator is actually only limited to the cloud because it's
Mhm.
built specifically to manage our own infrastructure with
Got
our
it.
own assumptions. We do have a Helm chart and an open source image on Docker Hub. So, and I've used that plenty more times than I can count, and that works
Okay,
just fine.
fair enough. So you basically support all clouds environment, all on premise, but when you go for QuestDB Cloud, that is AWS, which I think is a fair decision. It is the biggest environment by far. Um, so from a storage engine perspective, maybe how much can you share? Can you talk about some fancy details, like what kind of storage do you use? Do you use like the local NVMe storage attached to the virtual machine, or EBS volumes?
Yeah, so in our cloud, we have both actually NVMe and EBS.
Hmm.
Uh, Most customers end up using EBS, and honestly, EBS is simpler to provision. But I do want to actually talk about some cool stuff that we've done
Yeah.
with compression, because we actually never implemented our own compression algorithm. We're running on top of ZFS and using their compression
Yeah.
algorithm.
Okay. Yeah.
And
Cool.
yes, and we've actually there's an issue about data corruption potentially using Nmap on ZFS,
Hmm.
or rather a combination of Nmap and traditional syscalls, the pwrite and preads. And what we do is actually identify when we're running on ZFS and then decide to only use Nmap calls to avoid this issue. And I think what we've done is pretty cool also on the storage side of orchestrating this whole thing, because ZFS has, its own notion of snapshots, its own notion of replication, its own notion of Z pools. And to simplify things, again, because we're running this kind of, I don't necessarily want to say antiquated, but we're running a single tenant model, which might
Hmm.
not be in vogue these days. What we actually do is we create one Z pool per volume and throw our QuestDB on the Z pool, enable compression, and we've written our own CSI storage driver that sits in the middle of Kubernetes and other cloud providers, so that we're able to pass calls on to the cloud providers if, let's say, we need to create or delete a volume using the cloud provider API. But when it comes to mounting specific, ZFS and running ZFS related commands, we actually take control of that and perform that in our own
Hmm.
driver. I don't know when this is going to be released, but I'm actually talking about this in Atlanta next week.
No, next week is a little bit early. We're currently, I'm doing a couple of recordings, building a little bit of a pipeline because of conferences. Same thing. We'll be in Paris for KubeCon next week. So there is a little bit. No, I don't know exact date. I think it's like in 3 or 4 weeks. Um, so it's a little bit out, but I guess your talk may be recorded and public by then. So if that is the case, I'm happy to, if you drop it over and I put it into the show notes. People will love that. Um, so you said when you run on, or when you detect that you run on ZFS, you mmap. So you basically map the file into memory and you change the memory positions directly, and then you f-sync it, or how does it work? How do I have to think about that?
Oh boy. Okay. This is getting a little out of my. So we always use Mmap, like regardless. But the issue is when you combine Mmap with like traditional syscalls on
Hmm.
ZFS. And so what we do is we basically turn off those other syscalls and only use Mmap when we're writing to our files on
Right.
ZFS.
Ah, okay.
In
Yeah, okay,
terms
that
of the
makes.
specifics of when we sync and things like that, I wish I could answer right off the bat, but
That's totally fine. Um, so j just to sneak in a little shameless plug here. We should totally look into getting QuestDB running on Simplyblock. I think that could be a really interesting thing. It's because you mentioned ZFS, it's basically ZFS on steroids. If
yeah,
you if you want to
definitely.
call it that, if you can um put something higher on ZFS. I mean, it's a very, very high bar. ZFS from my perspective. I mean, I'm running a ZFS uh, file server in the basement. It saved me a couple of times with like broken hard disk. It's just an incredible piece of technology. I agree with that. And it's interesting because I've seen a lot of people trying running database on ZFS, and ZFS is all about reliability. It's not necessarily about the highest performance. So it's interesting you choose ZFS and you say that's perfect and it works great for us. So because we're almost running out of time, as I said earlier, 20 minutes is like super short. Um, when you look at like cloud and databases and the world as a whole, whatever want to talk about. What do you think is like the next big trend or the current big trend? What is coming? What do you think is like would be really cool?
Yeah. So guess I'm not going to talk about the existential crisis I'm having with Devin and the AI bots because that, it's just a little depressing for me right now. But I think one thing that I've been seeing over the past few years that I find very um, kind of interesting is this move away from cloud and back into your own data center. I think having, control over your data is something that's incredibly, important to basically everyone now. And I think it's to find the happy medium as, a DevOps engineer between, all of the wonderful, cloud APIs that you can use and, you know, going in the server room and kind of hooking things up. There's probably a happy medium there somewhere that I think is an area that is going to start growing in the future. You see a lot of on-prem Kubernetes type things, Kubernetes on edge maybe, um, and for me it presents a lot of interesting challenges because I've spent most of my career in startups, working on the cloud and understanding the fundamentals of, not just the cloud APIs, but operating systems and hardware a little bit. And so kind of figuring out where to draw that line in terms of um, what knowledge is transferable to like this new paradigm, will be interesting. And I think that's a new trend that I've been focused on at least over the past couple months.
That is interesting when you mention that, because it is kind of that, right? In when cloud became big, everyone wanted to move to the cloud because it was like cheaper in air quotes, right? And I think, well, the next step was like serverless because it is yet even cheaper, which we all know is not necessarily true. Um, and I see kind of the same thing. Now people realize that not every workload actually works perfectly or is a great fit for the cloud, and people slowly start moving back, or at least going back to not necessarily cloud instance, but co-located servers or like virtual machines, like plain virtual machines, and just taking those for the workloads that do not need to be like super scalable or super elastic. Yeah, well, thank you very much. That was very delightful. It was a pleasure having you.
Thank you
And
very much. Oh yeah, I enjoyed the conversation. It was great.
thank you very much. I do my best. No, it was, as I said, it was really good. Thank you for being here. And for the audience, I hope to well, not see you, but hear you next time. Next week. Thank you very much.
Thank you. Take care.